So here is part C of 2007 Form B from the AB exam, and we in part C want to show that if f double prime is equal to 0 for all x's, then the graph of g does not have any points of inflection. And the way that g is defined is right here. So g is defined to be f of x. So g of x, I'm just going to kind of write it out right here. And I'm thinking back to points of inflection. You know, a point of inflection is anywhere where a graph has a change in concavity. And concavity is determined by the sign of the second derivative, right? If the second derivative is positive, our graph is concave up. And if the second derivative is negative, our graph's concave down. So if we have a sign change for the second derivative of g from positive to negative or vice versa, we're going to have an inflection point anywhere where that happens on our graph. So I'm going to have to try to figure out what's going on with the sign of g double prime, and before we can do that, we're going to need to find g double prime. So if we go ahead and start by finding g prime, the derivative of this is just going to require an application of the chain rule. The derivative of the outer function, the derivative of f, is f prime, and we're going to leave this inner function f inside of that, and then we're going to finish our chain rule by multiplying by the derivative of the inner function, which would be f prime of x. So there is g prime. We want to know what g double prime is. So g double prime of x is going to be equal to the derivative of this. This is a prime here. Now, one thing I notice is that this is a product. So I'm definitely going to have to use a product rule when I go to try to find g double prime. And so this is going to be a little tricky, but as long as you're careful, it's not that bad. We want the derivative of this piece first. So this is going to require a chain rule. Outer function's f prime. Derivative of f prime would be f double prime, and we're going to leave this inner function inside of that. And then we're going to multiply by the derivative of this inner function, and the derivative of f of x would be f prime of x. So what I have here so far is just the derivative of this piece. I'm using a product rule, so now I need to multiply by the original second piece of the product, which is going to have another f prime tacked onto that term, because that is the second piece of the product. And then I'm going to have to add to that the original first piece. So I'm going to add to that f prime of f of x times the derivative of the second piece. So the derivative of this piece is going to be f double prime of x. So here is g double prime of x, and this doesn't look very nice at all, but we have something pretty useful for us to do what we're actually asked to do. We're told that f double prime of x is equal to 0 no matter the value of x. So you really have these two terms here added together. If you look at this first term, the first term is going to be a value of f double prime times f prime times f prime. We know this piece right here, no matter what ends up here, no matter what the value of f of x is, we know f double prime is equal to 0 for any x. So this piece right here is going to equal 0, and the product of 0 times something else is going to have to be 0. Similarly, f double prime is negative for all x, so this piece is also going to have to equal 0. If you have 0 plus 0, your second derivative for g double prime is always 0. If g double prime is always 0, there's no way that you can have a sign change for g double prime at any value of x. It's always 0. So since the second derivative is always 0, we have no points of inflection because there aren't going to be any sign changes on in the sign chart for g double prime.